Topic 9. Wave phenomena. Our first subtopic is 9.1 Simple Harmonic Motions. And we start with question 1. We have some introduction for the first 5 questions. It's about a 1.5 kilogram mass, which is attached to a horizontal spring. And it takes 0.75 seconds to make a complete oscillation when set in motion. So here in the center, this dotted line would be the relaxed spring without compression or refraction. But question 1 asks about it is pulled 4 centimeters to the positive x direction. So let's copy this one into our question. And I copied already the introduction and the picture, and now we have the question. We format the number that is given, and we start with the given values. And what's given? So we have this 4 centimeters given in our question. And let's look for our question here. So we should give the amplitude x0, the period t, and the frequency f of this oscillation. Well, once it's released, the force from the spring is to the left. So the amplitude is the maximum elongation, and so it's symmetric. Maximum would be 4 centimeters, so the amplitude is already given to us. So that's not really a question. This would be x0 as 4 centimeters as our amplitude of the oscillation. And that's explicit. Explicit given, and the answer as well. Second, we want to know the period. Symbol for period is t, and that's the time it takes to completely go from the starting point, make a complete oscillation coming back, and it takes 0.75 seconds to make a complete oscillation. Well, this one is also given. 0.750 seconds. Period of the oscillation, explicit. Not much of a task here. What about the third part? We want the frequency. Frequency, mass, no. This one is not given, so I think that's it that we can use. Now we need a formula. Let's have a look. Open our formula booklet. Here we are, topic 9. Simple harmonic motion, angular frequency. No, we don't have angular frequency yet. Acceleration, all these values distract us because we just introduced simple harmonic motion, which we already discovered and talked about in chapter 4. Waves. First subtopic of waves was 4.1 oscillations, and here's the formula that we take. Period equals 1 over f. Period t equals 1 over frequency, and from 4.1 oscillations. Now the solution is pretty simple. Just make the reciprocal of this formula. So the frequency is 1 over the period, and this would be divided 1 over 0.75. And even though we might we can, for the sake of fun, put it in here. So period equals 0.750. That's period in seconds. Formula is F equals 1 divided by period, and then print the frequency of the oscillation is placeholder hertz, period, and please format the answer of the frequency. Calculate and go ahead. So that's 3/4, that's 4/3, 1.33. Yes. Significant figures, force in meter has 2, the time has 3, mass has 2. So we go for 2 significant figures, which would be 1 after the decimal point. So dot 1 after the decimal point, try again, and then it's 1.3 hertz. So we can say 1.3 hertz. And to make it nice, we can also write an answer. Amplitude and period are given. The frequency of the oscillation is 1.3 hertz. Maggot math looks a little different. And question 1 for topic 9.1 is answered.